Let's take a look at differential equations here. And the first thing that we're going to have to do is define what we mean by differential equations. So when we're looking at them, the question is, what are differential equations? So first thing we need to do is get a definition. So a differential equation is any equation that includes a derivative term. So for example, you might see something like, just make sure I got enough space here, y equals y prime x. You might see something like y prime equals x to the fifth. You might see something like dy by dx equals 3x squared, or 3 dy by dx squared equals x squared plus y. There's all sorts of examples, but the point is somewhere in the equation you've got a derivative. And so we've worked with differential equations before, you just didn't realize that's a category of things we can call them. So you've seen something like this, right? Y prime equals x to the fifth. You've seen something exactly like this, dy by dx equals 3x squared. Those are differential equations. And so the solution to a differential equation is this, a solution is a function that, that solves. I'm trying to think of the word I want to use here. Solves the equation. And a solution can be verified by plugging in into the differential equation. So for example, if I said y equals f of x, if this was a solution to the differential equation I've got right here, then it would mean that, if I plug in y equals f of x and I plug in what, f prime of x times x, and I do my work through, I'll find that they're equal. So let's talk about the order of a differential equation really quickly. The order of a differential equation is the same as the highest order derivative that appears. So if you have an equation that just has first derivatives in it, that is a first order differential equation. So for example, dy by dx squared times y equals 3x squared plus 4xy. So yes, I've got a dy by dx squared, but it's only the first derivative. So this would be a first order differential equation. A messy one, but a first order one. Second order would be something like y double prime, say times 3, let's throw a divided by x. And I'm just throwing random things in here, obviously. Just to throw some interesting things in. But in this case, we see that we do have a second derivative right here. And we do have first derivatives, but we don't care about that. This is still a second order equation. Third order, we might have something like d cubed x dy cubed plus 3x equals y. I did a simpler one here because I think you start to get the idea. We'll just throw y double prime in there. Now, you don't have to have, just because it has a higher order doesn't mean it has to have lower order derivatives in it. It's just whatever the highest order that you have of derivative, that's the order we'd say for a differential equation. It doesn't matter a whole lot for this class, but that language is going to come up later. I just want you to be familiar with it. So we talked about how verifying differential equations was just by plugging in the equation. So we're going to do that here. So I'm just going to take this y and I'm going to plug it into my equation here. So we will need to rewrite it really briefly. D by dx of y plus 3y equals 6x plus 11. So I'm just going to plug in my equation. So d by dx of 3e to the negative 3x plus 2x plus 3 plus 3 times 3e to the negative 3x plus 2x plus 3 equals 6x plus 11. Again, we're just literally plugging in the thing that they've proposed as a solution and just seeing if we get a true equation. So the derivative of this first term right here is going to be 3e to the negative 3x times negative 3 plus 2 plus 0 plus 9e to the negative 3x plus 6x plus 9 equals 6x plus 11. This is going to be negative 9e to the 9x, which cancels with this term. I've got 0, so I've got 6x plus 11 equals 6x plus 11. This is a true statement, so this is a solution to the differential equation below, because we plugged it in and we got true statements. You can also do this by calculating the derivative first and then plugging that in directly. So for example, I can say, well, I know that y prime from this equation up here is going to be 6e to the 3x minus 2. And then I can just plug in y primes and y's, and so that would be 6e to the 3x minus 2 minus 3 times 2e to the 3x minus 2x minus 2 is equal to 6x plus 4. 6e to the 3x minus 2 minus 6e to the 3x minus, plus 6x plus 4, plus 6 equals 6x plus 4. These cancel, and we get 6x plus 4 equals 6x plus 4. Again, we see that we get a true statement, and you only need to go as far in these cases as getting to something that's obviously equal to each other to verify it. So the difference, again, just to reiterate, between those two processes, one, we just plugged in y everywhere and then took the derivative as it showed up in the equation. This method that I just did here was I took the derivative first because I knew it was going to come up, and then I just plugged them in. Both are interchangeable, it's just whatever method you prefer. And this is just a replica, so we're good to go.